window right now. All right, so here's a question I'd like to consider. Which of the following is the parent function for this function? Y equals, in brackets, 2/3 times x squared. So I'm going to show you the parent functions that you could choose from. You could choose from any of these four. So I don't want you to type it in yet. I just want you to think about it. Which of the following is the parent function for this modified function that's up there? Okay, I'm going to ask you to type your best guess into the chat box, but don't hit enter yet. Just type it in, but don't hit enter. Okay, go ahead. Hit enter and let's see what you think. Remember, we're taking a guess, maybe, or maybe you know for sure. Nothing wrong with being wrong, but there is something wrong with not giving it a shot. Let's see what you think. Okay, it looks like our most common answers, looks like no one has guessed A. So I'm going to cross that one out, and no one has guessed B. I can tell it's not B because there's no absolute value lines in there. So that makes sense. And it does have an exponent there, right? It's squared, so we know it's not a straight line. Okay, so C and D are our most common ones. Good answers, both of those. Those are definitely our best two. For this one, if it was D, we would see somewhere in there a square root. So that would be our indicator. Since we don't see that, our correct answer is going to be C. So here's what happened. They took the parent function of f at x equals x squared, and then they multiplied our x value in the brackets by 2/3. So it was transformed to now be, I should give it a different name because it's not f at x anymore. I guess this would be, I just want to make sure I'm naming these properly. We'll keep calling this y equals x. Oh no, sorry, I got that wrong. Our parent function was f at x. So that's good. It's this one that needs a new name. And we were calling it y, and that'll work fine. So we took our x squared, and we multiplied it by 2/3 inside the brackets. Okay, but it is associated, its parent function is x squared. And so what we're looking for when we're doing this is, can we identify the parent function? Is there a square root in there? That would mean it's a square root function. Is there those two straight lines? That would mean it's an absolute value function. Is it just an x to the exponent of 1, in which case it would be a linear function? Okay, so now we're going to look at combining combinations of transformations in some different parent functions, and then we'll go to Desmos and we'll try graphing some of them and see what they look like. So if you've got a parent function, and we're going to say, okay, we're calling that parent function y equals f at x. That's just what we're going to name it, f at x. Here are some transformations that we can have. Oh, pardon me. Looks like Smart Notebook is having some trouble. Let me see if I can fix that. There we go. Okay. So this is like the standard form for writing transformations. It doesn't tell you what the parent function is, but what it does tell you is the transformations you're going to do. Okay? So for the 11U class, this is something you're going to need to be familiar with, is this form. So I would recommend writing this down on a cheat sheet for this unit, or just having it handy on a sticky note, or however you want to do it, having it close by. Now you notice some of the names have changed. It looks similar to what we were doing before, but there's no K here, now it's a C. There's no H here, now it's a D. This one is called K, and this one is still called A, thankfully. So why did the labeling change? Great question. I don't know why the labeling changed. I'm following the conventions that are in your textbook, and those conventions are kind of like the ones that are used more broadly in mathematics. It's kind of annoying that those labels change, but they do, and that's how it's commonly referred to. So I'm going to follow the form that's in your textbook because I want what we do to match the homework problems or the reading you might do out of your textbook. Okay? So what this is describing a series of transformations that you would do. We don't know what the parent function is. All this is going to tell us is the transformations that we want to do, and then we could apply those same transformations to different parent functions. And that's actually what we're going to do with Desmos in a moment. But first, let's just take a look at what these different ones would do. It's very similar to the quadratics because this is just an extension of what we did with the quadratics. Okay? So here are our first points. Number one, A is a vertical stretch, compression, or reflection. So that doesn't change from what we did with the quadratics. That's still the same. It's a vertical stretch, compression, or reflection. If A is 2, we're stretching our y values by 2. If A is negative, we're reflecting in the x-axis. And if A is a fraction, we're multiplying our y values by that fraction, and they're getting smaller. So I'm just going to write a little note here and add to this. I'm going to try and match my colors here. We're going to say multiply all y values by this. So whatever our A value is, we're going to multiply all of our y values by that. That could stretch it or compress it, depending on what A was. Or if A was negative, it would reflect it. Here's our next one. This is our K value. Now the K value, I know this is a pain, and I don't know what to tell you. I apologize. It's just the way mathematical form is written with this stuff. Our K value is not the same K values we saw before. Now it is one that's inside the brackets. For the 11M class, you don't actually do this part, although you could have with quadratics, but it's not included in your curriculum. So in this case, it's inside the brackets and it's multiplying what's in the brackets, but it's like inside the function. So K is a horizontal stretch, compression, or reflection, but it's a little different. Like our thing inside the bracket that moved it the opposite direction, this one is similar in that instead of multiplying our x values by this, we're actually going to divide all of our x values by this. So whatever our k value is, we're going to divide all of our x values by this. And this will get a lot easier when we're using Desmos. I'm not going to have you doing grinding out graphing by hand, because that is very painful to do, and I don't honestly think is that really helpful in your understanding of the math. if you understand that whatever this k value is, you're going to take that and you're going to divide all your x values by that. That's all you need to know. Now there could be a reflection as well. If this value is negative, that means it's going to be a reflection in the y-axis. So it's going to reflect it in the y-axis. And we'll have a look at that. D is one that we're used to. We used to call this H when we were doing just quadratics. It's just a horizontal translation, left and right. And you remember you do the negative of it. And C, same thing, vertical translation up and down. So D and C are easy. Really all we've done here is we've added this new, we've kind of renamed things and we've added this new K value. Now I want to bring over another little thing here. Let me grab it and put it in a space where it's easy to read. I'm just going to tuck it in here. So here's a little pro tip. Values that are inside the brackets affect your x values. Things that are outside the brackets affect your y values. So things inside the brackets affect your x values, things outside the brackets affect your y values. So A and C, because they're outside of the brackets, affect your y values. K and D, because they're inside the brackets, affect your x values. Sorry about this thing at the bottom that may be a little hard to read. I'm going to see if I can move that down a touch. Just so it's not in the way of these, oh, here we go, of the Smart Notebook limited mode thing.
Please dismiss students to ride buses north 9 and north 10.
Okay, so I actually want to try this on Desmos, and we're going to try one of our parent functions instead of our quadratic, and we'll have a look at how this affects it. Okay, so let's get the Desmos graphing calculator set up here. I'm just going to move this a little bit, folks, because currently my recording will not record the whole thing. So I'm going to adjust this a little bit so that if you watch the recording back later, you'll be able to see the whole thing. All right. So here's my good old Desmos. And I'm going to clear this off, and I'm going to put in one of my functions. I'm going to start with one of my parent functions. Let's start with the square root function. Let's do that one. So I'll say f of x equals, and I'm going to need to go down into my keyboard here and make my square root and put an x there. There's my square root function. Okay, so there it is. It's looking good. It's just hanging out. I can add some changes to this though, so let's do that. Let's start by putting a 2 out in front. That's going to be my a value. When I put in that 2, what it should do is it should multiply all of my y values by 2, which is going to stretch things out in a vertical direction. Let's go for it and see what it looks like. Boom. There. It's stretched out my graph in the vertical direction. Now, if I were to put a negative in front of there and make it actually -2, it should also be reflecting it in the x-axis. So let's try that. There it is. Now it's reflected in the x-axis. So I multiplied all of my y values by 2 to stretch them. and then it also multiplied it by -2, which reflected in the x-axis. So now it's down there. Okay, let's keep going. Let's put some brackets around this x.
First floor on the reflection are now dismissed. First floor on the reflection.
Okay, let's put some brackets around that x. And now in front of that, let's put a, I don't know, let's put a 3. So what that's going to do is that's going to divide all of my x values by 3. So actually, let's do a 4. That'll clean it up, make it a little neater. So right here on my graph, I see I have a point of 4, -4. 4, -4. So if I divide my x values by 4, that point should move over and be 1, -4, because my x value will be divided by 4. So let's do that. I'm going to put a 4 in there, and boom, all of my x values were now divided by 4. That's what that 4 in there did. Okay, cool. Now let's do a little shifting left and right and up and down. Let's start by shifting to the right 2 units. So how do I do that? To the right is a positive direction, so I have to subtract instead. So in the brackets, I'm going to go -2, and that's going to move it over to the right 2 spots. Let's actually make it 3 spots, so all my numbers are a little different. Okay, and now finally I'm going to need to tab right to the end, so I'm out of that square root sign. I'm going to move this up 1 spot. So I'm going to add a +1, and all the y values have 1 added to them, moving it up 1 spot. So this is my square root function, but I've done 4 different types of transformations to it. My a value was a -2, so it stretched it out by 2. My y values, I multiplied my y values by -2, which stretched it out and flipped it. My k value is a 4, which means I divided all my x values by 4. My, I can't even remember what they're called anymore. Let's go back to the list. My d and my c. My d was a -3, so that moved me to the right 3 spots. And my c was a 1, which moved me up 1 spot. Okay, so I use -2, 4, -3, and 1. I would like you please to open Desmos, and we're going to try one right now where you're going to give this a shot.
On the reflection, second floor on the reflection.
So I'd like you please to open Desmos right now, and we're going to give one of these a try. So I'll give you a moment to do that, whether it be on a phone or a tablet, computer, in a new browser window, whatever. Open up Desmos now, and we're going to try a new parent function. Can you just type me, just say ready in the chat when you're ready to go and you've got Desmos open and you're good to go. Okay, I see a number of people are ready, so I'm gonna begin. We're gonna start with the absolute value function. Okay, so I want you to follow along and do this the same as me. I'd like you to put in the absolute value function. That's the one with the straight bars. So you're gonna need to use your keyboard. Hit it once, put in an X, and then hit it again. And that should give you this function right here. It looks kind of like a big V. Are you on Desmos, Mateo?
First floor, even number classrooms are now. First floor,
Okay, so that's no problem. That's no problem, Mateo. Let me show you how to do it. So in Desmos, you should have a little plus arrow up here. Let me refresh, so I'll be looking exactly the same as yours. Okay, so we should have just a space here. I'm going to write first f at x with brackets. And then I'm going to look for my keyboard. Now my keyboard is down, for me it's down here in the corner. It says show keyboard. So I'm going to click that and my little keyboard will pop up. Okay, so you're going to need to look for your keyboard and see where it is so you can get that keyboard to pop up because we're going to need that. So we're going to write f at x equals, that means we've got our function ready. We're going to hit our absolute value button once. Now that looks like an A with lines on either side of it. So I'll ask you to hit that once. That'll put that first line there. And then we'll put an X in the middle. And then we'll hit that button again, and that's going to close it off. And now we've got an absolute value function. It's basically a straight line that can only be positive. It can only have positive y values. So it can't go into negative y values. It can only have positive y values, and that's why it looks the way it does. So now what we're going to do is we're going to do some transformations to it. I would like you, please, to start off by reflecting this in the x-axis. So if you know what to do, type it in, reflect it in the x-axis. If you're not sure, I'm going to show you in just a moment.
second floor, even number classrooms are now. Second floor, even number classrooms.
Okay, so to make it reflected in the x-axis, thanks, Kellen. I appreciate that. I appreciate the heads up. I'm going to put a negative in front, and all of a sudden, it's now going to be pointing downwards. Yeah, Sam, that's exactly right. We put a negative in front. Now I want you to do a vertical stretch by a factor of 2. I want you to stretch this out vertically by a factor of 2. Well, how do we do that? We multiply it by 2. And now it's stretched out kind of thinner, skinnier function. Now I want to divide all of my x values. So this is going to be a horizontal compression. I want you to divide all of your x values, doing a horizontal compression by a factor of 3. So try that, and in a moment I'll show you how to do it. Okay, now the easiest way to do this is to put some brackets around your x. I find that helpful, although you wouldn't have to, but I find it helpful to kind of help me make sure I'm not making any mistakes. And I'm going to put a 3 in front. That's going to divide all of my x values by 3. And so that is a horizontal compression. It's squishing it horizontally, which looks the same as a vertical stretch. So horizontal compression and a vertical stretch look the same. And basically they are the same operation. Okay, now I'd like you to move this to the right 4 units. I'd like you to move this to the right 4 units. Okay, so to do that, we're going to put a -4 inside our brackets. That moves it to the right 4 units. And last but not least, I want you to move it up 1. So to do that, we're going to add a +1 right on the end, and it's moved up 1. Okay, so that's our absolute value parent function. I want to go through just a couple of others, and I want you to follow along and type it in as I do it so that you can get comfortable typing these into Desmos. So we're going to kind of do these next couple simultaneously. Okay, we've done our square root function, we've done our absolute value function, we've already done quadratics. The straight lines are pretty simple, so we're not going to bother with them, but I do want to do the reciprocal function because it's a little tricky. So I'm going to hit the plus, and I'm going to add a new expression. And I'm not going to call it f at x because that would confuse my graph. I'm going to call this one g at x to give it a new name. And I'm going to hit, I can either use my division symbol, but I'm just going to actually use my keyboard for this. But if you don't have a keyboard, you could just use the Desmos keyboard. I'm going to go 1 and then hit the slash button for dividing, and it knows it's doing it for me automatically. 1 divided by x. And there's my graph in blue. I'm going to start by doing a vertical stretch and a reflection in the x-axis. So I'm going to do the same as I did before. I'll throw some brackets around this to make my life easy. And then I'm going to put a -2 in front. I'm going to multiply it by -2. So it reflected it and stretched it. Next, I'm going to do a horizontal compression by a factor of 3, so I got to multiply it by 3, which I'll do. And that's inside the brackets. Note, I could write it like this, or I could just make the top a 3 instead of a 1. That's the same thing, because 3 times 1 over x equals 3 over x. Now let's shift it 4 units to the right. I'm going to go down here where the x is on the bottom, and I'm going to put in a -4. And that's going to shift it 4 units to the right. And finally, I want to shift it 1 unit up. So I'm going to get all the way outside those brackets, and I'm going to go +1, and then I'll shift it up 1. So these are the exact same transformations, but they look a bit different because this is the reciprocal function. So I want you just to kind of see how these look. Of course, we had our third one we can call t at x. And that was our square root function. So with our square root function, we can say same sort of thing. We got a -2 in front. Oops. We got a -2 in front. We're multiplying our x by 3. And we're subtracting 4 from our x value. And we're adding 1 at the end. So there's our square root function. So these are all the exact same transformations done on 3 different parent functions. And we could do the same thing to our quadratics. Okay, so we're going to use Desmos. When you're doing test writing and exam writing, you can use Desmos. And I want to encourage you to do that because I think it's an awesome tool. And something when you're actually problem solving you could use. And so we'll do that. Okay. I want to end on just one more question, like a multiple choice question to think about. And then I think I need to rethink the homework questions a little bit. Because the way I set this up, we moved a little slower than I had anticipated, which is on me. But I'm going to have to rearrange the homework questions, so I don't want you to check them on Edsby for about 15 minutes. Okay, so I can fix them. I'd like to end here. Thanks for letting me know, Dasha. That's fine. I want to end here. The solid graph has been compressed horizontally by a factor 1/2 relative to the dotted graph of y equals x squared. So we've got a dotted line. That's our regular y equals x squared, our regular quadratic. The solid graph you're going to see is the one that's been compressed horizontally by a factor of 1/2. So it's compressed. And there's what it looks like. So the dotted line is y equals x squared. Horizontally, it got compressed to look like the new one. Question is, which of those equations is the equation for the solid graph? Tough one. You don't have to have an answer, but if you want to take a guess, and I'm going to make this one optional, if you want to take a guess, you can type your best guess into the chat. This one is tricky, so I expect I'm going to get some incorrect answers, and that's always okay. If you want to take a guess, go for it. Okay, the guesses are rolling in, and it looks like B and D are the common answers. And this is actually one that's kind of meant to trick you a little bit. So I want to go over to Desmos, and we're going to finish off here so we can actually confirm whether it's B or whether it's D. So we do a transformation, and it ends up squished. Which is it, B or D? So let's get a new Desmos page here. Here's our function. Here's our first one, x squared. Now our next one is going to be a compressed version. Let's try both. So let's go g at x and see what we get. Equals, and we're going to go 1/2 times x squared. So it looks like that one is not correct. Looks like that one is not correct. Let's try our other one and see if we get a compressed one. We'll go t at x there it is. So the green one is the one we want, and so it looks like D was our correct answer. So this is where language gets tricky, and what we got to focus on is compressed, meaning it's squished inwards. And how do we squish it inwards? We put a 2 in there, and when we put a 2 in there, that multiplies our x values by 1/2. So this is a question from that question bank. It's very nitpicky. And my goal is going to be never to try and like trick you with language. It's going to be to see your understanding. But just to warn you that like textbook questions and stuff like this will often have a lot of this nitpicky language. So B and D were both really good answers. That means you understand it and you're on the right track. In this case, D is the correct one. And sometimes you might need to graph to be able to know that for sure. Okay, folks, it's that magic time. Thanks. This went a little slower than I thought, but that's on me. That's because maybe we just need to take a bit of time. So tomorrow we'll revisit this a little bit. We'll do our inverse functions and keep on trucking as we go. I am going to change the homework a little bit. So again, don't check it for 15 minutes until I've had a chance to change that. And I'll ask you, since it's that magic time and you have to go for lunch, to unmute and say goodbye to your wonderful classmates, and I'll wish you a great rest of the day. Have an awesome rest of the day, folks. It's fun doing math with you as always. Happy Monday, and I'll catch you soon.